Hi. So the fireball you're seeing at the start of this video, that's one of my buck converters going up in flames. Why? Because I was stress testing a bunch of them. You see, I use buck converters all the time in my projects, especially when powering development boards, sensors, and microcontrollers. I usually run everything from a 24-volt power supply, so I need solid, safe step-down converters to get 5 volts reliably. Safety first. I'm stress testing low-cost buck converters with a 24-volt supply and a stepped electronic load in a controlled setup. Do not try this yourself. Power electronics can fail violently and start fires. Now, if you're not already familiar with how buck converters work, here's a super quick explanation. No math, no theory, just the concept. Imagine you have a power loop and a fast switch. If you rapidly turn the switch on and off, the average voltage coming through drops. Now, if you add a capacitor and an inductor to smooth things out, you get a clean, lower output voltage. That's what a buck converter does. Switch fast, smooth the signal, lower the voltage. Simple. Now here's how I ran the tests. I picked 6 DC-DC step-down converters. For each one, I connected the input to a 24-volt bench power supply and set the output to 5 volts using a 150-watt, 20-amp electronic load tester. I started each test at 5 watts, then increased the load step by step, roughly every 5 seconds, until the module either shut down, throttled, or failed completely. While testing, I also recorded the switching waveforms of each converter using an oscilloscope directly at the switching SW node to see the real square wave signal each one produced. You'll see those waveforms during the video as well. And to track how hot things got, I filmed the whole test with a thermal camera. That's what you'll see in the top right corner during testing. It shows the actual temperature rise as the load increases in real time. During these tests, I took safety very seriously. I had a powder fire extinguisher next to me, a large container of sand, and a fire alarm wired to a central system. I was working in a well-ventilated area on a metal surface using metal clamps and wearing safety glasses the entire time. Testing electronics until they fail can be extremely dangerous, so please don't take this lightly. Let's get into the actual testing. The first module was a mini fixed output buck converter. It claims 3 amps max at 5 volts, so about 15 watts. Everything looked good until I passed 19 watts. Then, suddenly, the IC popped. One of the legs literally burst with a tiny firecracker-like spark. No shutdown, no protection, and no recovery. Dead. The second one looked almost identical. Different manufacturer, same design. It also claims 3 amps. It failed at 14 watts. A little more smoke than the first one. Just another dead converter. And again, no protection or recovery. Now the third one. This one deserves its own story. It's an adjustable buck converter, but it's not plug and play. First, you have to cut a trace on the PCB just to activate it. Then you need to solder a pad to select your output voltage, 5 volts in my case. And the wiring is strange. It doesn't have 2 clearly labeled output terminals. Instead, there's only one solder pad for the output negative, which is shared with the input ground. That's not electrically wrong. All of these modules share ground. But physically, it's confusing and very easy to wire incorrectly. It also has an enable pin that must be tied to VIN for the board to turn on. I tried testing it at 24 volts input, but it wouldn't even power on. I had to lower the input to 18 volts just to get it working. Then I slowly increased the output load, and suddenly, bang, sparks, smoke, fire. It caught real fire, not just a component failure. I had to put it out manually. The fourth module is completely different and in the best way. When I reached around 10 watts, the module didn't fail. It just shut itself down. Once I reduced the load, it started working again automatically. It has real protections over current, thermal shutdown, short circuit. It's well designed and it recovered perfectly after overheating. This is probably the one I'll use to power my ESP32s in the future. The fifth one, it's also adjustable and has some protection circuits on paper. I tested it up to 21 watts, then it just died. No smoke, no fire, no sparks, just silence. The onboard LED turned off, and that was it. I think the diode or IC failed internally. It didn't recover, but at least it didn't burn. Still, no warning, no cutoff, just dead. Finally, the sixth converter. It's the biggest module of the bunch, and it has both voltage and current adjustment. It even has LED indicators for when it's in current limit mode. I tested it up to 20 watts, and it handled it perfectly. When it got too hot, it throttled the output, and when I pushed it too far, it shut down briefly, and then came back after cooling. This one is more expensive, but for higher power loads. So this whole thing is kind of like an elimination round. a survival game. To be fair, all 6 converters met their claimed output specs, and most of them even went beyond what they were rated for, at least for a short time. Some of them even claimed to have built-in protections like thermal shutdown or overcurrent limits. But in practice, those protections either didn't trigger or weren't enough to prevent failure. But again, this was a stress test. I deliberately pushed every module far beyond its rated specs, well past what you'd expect in normal use, to see how they behave under real pressure. Out of the 6, 2 converters made it through, number 4 and number 6. These are the winners. And they'll move on to the next phase of testing, where I'll run them under continuous load for longer periods to see if they're truly reliable over time. For now, though, they've shown real promise, not just surviving the stress test, but protecting themselves, shutting down cleanly, and recovering without damage. Thanks for watching. If you liked this, hit that like button, subscribe, and drop a comment if you have questions, suggestions, or want me to test a specific converter in the future. See you in the next one.